For centuries, astronomers have scoured the skies night after night without ever spotting them. But hidden behind the familiar stars and quiet galaxies close to our universe lurks something much more frightening, powerful, and completely invisible to the human eye. Initially, they appeared only as distant specks emitting strange radiation. Fortunately, they are not nearby. If they were, they would flood our galaxy, our solar system, and our planet with deadly radiation. A single one of them can emit more than 40 quadrillion joules per second. By comparison, our sun emits around 34 quadrillion joules per year, 1,000,000 times less. The brightest of these monsters can dazzle stars, galaxies, and even 1,000 galaxies at once. Extreme events, such as the most powerful supernova, can outshine these cosmic beacons, but they are ephemeral, shining brightly for weeks and then fading away. When they wake up, they remain active for millions of years. In a fraction of their life, they produce more energy than the most intense cosmic explosions. They devour everything around them and are capable of tearing entire stars apart, producing flashes of radiation and jets of charged particles that cross millions of light years, piercing galaxies and spreading destruction far and wide. They are the quasars, the most powerful machines in the known universe. The quasar furthest from us is 13 billion light-years away. It would take almost the entire history of the universe to travel there, and that's not even counting the expansion of the universe. Space is vast and getting bigger, and sometimes that can make us feel small. In the 1950s, astronomers thought they knew almost everything about the universe. They imagined a cosmos where our galaxy, the Milky Way, was just one of many, all floating in seemingly boring vastnesses of space. The universe seemed to be, at most, only a few billion light-years across. And then came the technological revolution. In the 1930s, pioneering engineer Carl Jansky was tinkering with his radio antennas when, lo and behold, he discovered signals coming from deep space. And they weren't just any signals. Some came from small, distant, and very mysterious objects that emitted radio waves over a wide range of lengths. These strange objects were scattered across the sky, both inside and outside the Milky Way band. But come on, if they're so close, why can't we see them with our optical telescopes, you might ask? And if they're so far away, how can they be the brightest objects in the universe at radio wavelengths? Finally, in 1962, thanks to the refined techniques of radio astronomy, astronomers Sirroa Hazard and John Bolton had a brilliant idea. They used occultations of the moon to locate one of these strange radio objects, known as 3C273. Then, eagle-eyed astronomer Martin Schmid found a visible object in the same place. Within this visible light, he saw an unusual collection of bright spectral lines and dark gaps, the fingerprints of the elements and molecules scattered throughout the cosmos. But these lines weren't where they should be. They were shifted towards the red by almost 16%. This meant that 3C273 was either moving away from us at an incredible speed, or it was incredibly far away. And then, when they interpreted this redshift, astronomers fell over themselves. 3C273 was 3.4 billion light-years away. It was the most distant object ever observed, a true cosmic celebrity that even appeared on the cover of Time magazine in 1966. But wait, there's more. 3C273, despite its incredible distance and brightness, was extremely compact, smaller than our own solar system. Year after year, it appeared on old photographic plates, but nobody had recognized what it really was until then. In the constellation of Sagittarius, where the Milky Way shines brightly, astronomers have discovered the core of our galaxy. From observations with radio telescopes, they have identified a bright source of radio emissions. This point has been named Sagittarius A. Just imagine, at the heart of Sagittarius A, stars revolve around something massive and invisible, bound by gravitational currents to an object with more than 4 million times the mass of the Sun, a supermassive black hole. But how did something so gigantic come to exist right in the center of our galaxy? In 2022, the Event Horizon Telescope revealed an impressive image, a bright ring of plasma swirling around a dark, empty core. This is the black hole itself, distorting gravity to such an extent that the light around it bends, offering us a view from all angles in a single image. But then, you might ask, are black holes related to quasars, those distant light sources in the universe? The Big Bang Theory tells us that the structures in the universe grew from small differences in density. Over millions of years, these differences increased, pulling in matter and creating incredibly high densities in the centers of galaxies. Massive stars die young and become black holes, which, confined in small spaces, merge and grow uncontrollably. In the past, the idea that black holes could power quasars seemed like a distant hypothesis. But then, in 1972, the system known as Cygnus X1 challenged this view. Observations revealed that it was not one star, but two, and the intense X-ray emissions came from the plasma around a black hole. Today, we know that supermassive black holes reside at the center of almost all galaxies, including our own. They are difficult to see directly, but the luminous emissions of quasars help us measure their masses. Let's say you're in command of a spaceship, going through a storm of cosmic rays that threaten the integrity of its hull. Alerts flash frantically, while microscopic particles infiltrate, invading the crew's core. But you, determined, push your ship towards a maelstrom of plasma at a relativistic speed, where the laws of physics as we know them simply no longer apply. You are at the mercy of these colossal forces in free fall, while the life support system begins to fail. The outside of the ship reaches temperatures of millions of degrees Fahrenheit. Yes, that's right, millions. Suddenly, everything calms down. Silence takes over. The alerts cease. The outside temperature plummets to almost absolute zero. And then, right in front of you, you realize that you can't see anything. The reason for your mission, the supermassive black hole, the invisible heart of the galaxy. Did you know that the core of our galaxy is like an overcrowded urban center? That's where red giant stars and smaller black holes abound. But it's inside a thick, cold ring of dust that the real spectacle takes place. This ring blocks our view of the galactic core, absorbing the radiation emanating from it. We can only see the cosmic chaos when we look from above or below this ring. Now imagine stars venturing dangerously close to the black hole, accelerating to almost the speed of light before being torn apart. Their atoms are dragged towards the event horizon, where the black hole's gravity is so overwhelming that nothing can escape, not even light. But how can this create something so powerful that it can be seen across the cosmos? The key lies in the accretion disks, where gas and dust fall into the black hole, heating up to incredible temperatures and emitting a monumental amount of energy. This energy doesn't just heat up. It pushes the gas away from the black hole in a continuous cycle of collapse and expansion. But how, despite all this chaos, can supermassive black holes maintain such a delicate balance and continue to shine for millions of years? The answer lies in the complex dance of gravitational forces, friction and magnetic fields that transform potential energy into spectacles of ultraviolet light and cosmic rays. When we look at the nucleus of a galaxy head-on, we see a quasar, one of the brightest objects in the universe, capable of outshining 1,000 galaxies put together. And if we are aligned with the jet of a quasar, we see a blazar, one of the most extreme emissions known. To understand what a blazar is, we first need to know that quasars are extremely active and luminous galactic nuclei, powered by supermassive black holes at the center of distant galaxies. They are known for their incredible ability to emit huge amounts of electromagnetic radiation, mainly due to the superheated material in the accretion disks that surround these black holes. Now, what makes blazars special is the fact that, in them, the jet of radiation emitted by the quasar is aligned almost directly with our line of sight. In ordinary quasars, these jets are emitted in directions that don't necessarily point towards the Earth, so we mainly observe the radiation from the accretion disk. In blazars, on the other hand, the jet is oriented towards us, which dramatically intensifies the radiation we perceive. This orientation makes blazars extremely luminous and variable, exhibiting rapid and dramatic changes in brightness. They also emit strongly in all bands of the electromagnetic spectrum, from radio waves to gamma rays. Because of these characteristics, blazars are considered to be some of the most energetic and dynamic objects in the universe. Astronomers have a puzzle on their hands. If black holes are formed by the death of giant stars, how did they exist before the first stars died? These first black holes were only a few times the mass of the Sun. So how did they get so big? They have two options: merge with other black holes or attract and accumulate matter. But just look at the irony. The very phenomena that keep quasars shining for millions of years also prevent large amounts of gas from reaching the black hole quickly. It's like trying to inflate a balloon with a gale blowing against you. What's more, there's an additional mystery. Although we have detected smaller black holes merging, we hardly see any black holes with intermediate masses. This raises a big question. Where are they? To try to solve these puzzles, we have built telescopes like the James Webb, which is exploring the first generations of stars, galaxies, and quasars. These studies show us that galaxies and their supermassive black holes are incredibly connected. Their relationship is so intimate that the behavior of one profoundly influences the other. And if you're as fascinated as I am, don't forget to like and subscribe to the channel. Leave a comment with your impressions or questions. Who knows, maybe your curiosity will lead us to even greater discoveries. Thank you very much for watching, and see you on your next cosmic adventure.